So if you see in the first one, the replacement set is 1 to 10, 1, 2, 3, 4 up till 10. X less than 4 is your inequality. So X here can assume values that are only till 1 to 10. Okay, so what are the integers here? Is 1 less than 4? Yes, it is less than 4. Then it will be a part of the solution set. Okay, solution set. Next, consider the next one. 2. Is 2 less than 4? Yes, I'll have 2 in my solution set because it is satisfying this inequality. Let us consider next 3. Is 3 less than 4? Yes, 3 is less than 4. That means 3 will be a part of the solution set. Consider the next one. 4. Is 4 less than 4? No, 4 is not less than 4. That means it will not be a part of the solution set. Similarly, 5 less than 4 is not true. Therefore, it will not be a part of the solution set. So your solution set will be only 1, 2, and 3. Okay. Similarly, for the other 3 also. Okay. Now look at the last one only. The solution set here is the replacement set, in fact. If you see the last one, the replacement set here is the replacement set is 5, 6, 7, 8, 9, and 10. This is a replacement set, and the given inequality is x less than 4. So x can take values from this set only. So what are the values of x that are less than 4? So 5 is 5 less than 4? No, it is not. Is 6 less than 4? It is not. 7 less than 4? It is not. And similarly, you see that all the values in the set are not less than 4. That means they do not satisfy the inequality. So there is no value actually that satisfies the inequality. So therefore, I'll write solution set is a null set. We say solution set is equal to null set because it does not satisfy any inequality. Okay. Okay. So this is about your replacement set and your solution set. Now there are some rules that are there. You can see, go through the rules. That is, the first rule is you can add or subtract any number from both sides of the inequality. I've given you with examples. Okay. Next is just as in your class 8, I mentioned all this, that you can add or subtract any number to both sides or from both sides. In fact, to both sides. You can add any number to both sides and subtract any number from both sides. Second is any number can be transposed from the left hand side to the right hand side as long as you are changing the sign. That is, your just like your linear equations or your equations where you are changing from one side to another and you are changing the sign. The rule here remains the same. Third one, we can multiply or divide both sides of the inequality by the same positive number. If you see, I have underlined positive number. Okay, now many of us make this mistake that uh, when we are multiplying or dividing both sides of an inequality by the same positive number, or under, if not a positive number, then the confusion happens when you're not dividing by a positive number. Okay, so suppose I write 4x is less than or equal to 8 as here. Okay, that means x is less than or equal to 8 by 4. Why is it equal to 8 by 4? Because I am dividing both sides actually by 4. So 4x less than or equal to 8. I'm dividing this side by 4 and I'm dividing this side by 4. Why am I dividing this side by 4? In order to make this x. In order to make the coefficient of x 1. That's why.
Sir, we can directly write x is equal to 8 by 4.
If you don't make any mistakes, you can write directly. You can do a lot of things directly if you don't make any mistakes. Okay. Next
Okay,
is
sir.
we can multiply or divide both the sides by the same negative number but the inequality sign has to be reversed. So now if you have, say, minus 6x less than or equal to 12. Now this is the problem when you are doing directly. Okay, see what happens. You understand that you do directly, and all the rules of the all the rules of the equation applies here also. So what you do, this is the common mistake. See a mistake that what you make. What you do is you write, just because you wrote for 4x, what was the earlier one example here? For your 4x less than or equal to 8, for your 4x less than or equal to 8, you were writing what? Directly you were writing x less than or equal to 8 by 4. Now see what happens here. If you are doing things directly, then what will happen here? So minus 6x less than or equal to 12, if you are doing this directly again, just like I had done in the right hand side, you, you write x less than or equal to 12 by minus 6. That means you get x less than or equal to minus 2. Okay, but then this is wrong. This is wrong because just because you were doing it this way here, you did it this way here also. Okay, but actually this is wrong. Why is this wrong? Because you did not keep in mind that the sign of the inequality had to be reversed. That is, when I was writing x less than or equal to 12 by minus 6, I had to reverse this inequality sign from less than or equal to greater than or equal to. And that was a mistake. And why did I have to change this inequality sign? Because I was dividing both sides of the inequality by a negative number. The actual step would have been this way. Because I want to make the coefficient of x 1, I divide both sides by minus 6. So divide by minus 6. And because I'm dividing by a negative number, this less than or equal to will now change to greater than or equal to. So now that will become x greater than or equal to minus 2. Okay, so the previous solution that I showed you was a common mistake that people make. Now I've given you some how to graph the solution sets on the number line. Okay, when x is a natural number or a whole number or an integer, it is very easy. Okay, but what happens when it is a real number? That is now what your main concern is in this class 10, because real numbers, how to graph solution set of real numbers was I had not discussed it back in class 8. Now suppose you have got a solution set like this. Consider this one. Consider this one. You have got a solution set like this: minus 4 less than or equal to x less than minus 2, where x belongs to set of real numbers. Then how do you graph this on the number line? Okay, so what you do here is you take your number line, okay, plot the points. Now see, look at the points here. X is minus 4 is less than x. So the lower number is minus 4. Remember, whenever you are writing any inequality in this form, a less than or equal to x less than or equal to b, remember a has to be the lower number, b has to be the greater number. So so in this case minus 4 is the lower number, so I have a minus 4 here, say. Okay, and say I have a 0 here, and say I have a minus 2 here. Okay, so how will you graph this on the number line? Now if you see, you have an equality sign here, but you don't have an equality sign here. Because you have an equality sign attached to minus 4, you will give a vertical line just above minus 4, because x is touching minus 4. Okay, and because you don't have an equality sign attached to your minus 2, you will give a curved line here. You'll give a curve, in fact, because you're not touching minus 2, and you will join these two. Okay, so this means that part, this entire part of the line, this entire part, in fact, this entire part of the line except a very small part. See, I have not touched minus 2. Okay. All this gives you your solution. Any point on this line gives you your solution. So actually the solution set is infinite. Please remember that when you are getting this kind of a set as your solution set, this kind of a set as your solution set, then the solution set is where the replacement set is a real number, then this is an infinite set. Solution set is an infinite set. But if I change when the replacement set is a set of real numbers. But when I change the replacement set to say x belongs to n, then what does the solution set become? In this case, no natural number lies between minus 4 and minus 2. Solution set becomes a null set when the replacement set is a set of natural numbers. Let us say, what if I change this replacement set to a set of integers? Then what will happen? Solution set, what integers lie between minus 4 and minus 2? Minus 4, because there is an equality sign here. So I have to include minus 4, minus 3, minus 2, minus 1, not minus 2, minus 3 till minus 3 only. And it will not go to minus 2 because there is no equality sign here. So only the solution set will only have minus 4 and minus 3. Okay, so I don't think there should be any doubt here, but anything that you want to ask? Let's move on to the sums if you don't have anything to ask. I've already solved a
Sir,
few sums. Yes. Who asked what? You can hear me clearly? Abu, you can hear me clearly?
Yes, sir.
Okay. Then let's continue with some sums. Let us try with number 25 first. Now, all the earlier sums are easy in nature. If you are able to work out these sums, you'll be able to do the sums. 25. The given inequality here is minus 1 less than or equal to 3 plus 4x less than 23. Okay. Also, given that the replacement set is a set of real numbers. We first write the replacement set. Take note of the replacement set. Replacement set is a set of real numbers. That is done. Now, if you see, this inequality consists of two inequalities. So we'll divide this into two and then work. The first part is minus 1 less than or equal to 3 plus 4x. This is the first inequality. And the second inequality is, first inequality we have taken this part. Okay, and for the second inequality, we take this part. Okay, so 3 plus 4x less than 23. Now we are going to solve these two inequalities. So we have minus 1 minus 3 less than or equal to 4x. Minus 4, so you're transposing my 3 to the other side, and equal to 4x. Now see, in order to find x, I have to make the coefficient of x 1. So I need to divide both sides by 4, which is a positive number. If I want to divide both sides by 4, I will not change the sign of the inequality because I'm dividing by a positive number. I'm getting minus 1 x. Now, if I change the order, that is x I want to take it on the left hand side and minus 1 I want to take it on the right hand side of the inequality, then I will have to now change the sign of the inequality. Okay. So that is the first part. Any questions on any step here in the first part? If not, then let's see what the second part is. So here what I do is I write this as 4x less than 23 minus 3. 4x less than 20. Again, in order to make the coefficient of x1, I have to divide both sides by positive number, 4. So I don't have to change the sign of the inequality. Means we get x less than 5. So what you see here is that you are getting x greater than or equal to minus 1 and you're getting x less than minus 5. So for the first inequality, consider this inequality. What is the solution set here? Solution set of this inequality. Remember, it is a set of real numbers. Okay. So solution set will always be given in set builder form because it is an infinite set. So solution set in this case, let us call it E. Solution set in this case, we write it in set builder form x such that x greater than or equal to minus 1, where x is a real number. This is the solution set. Okay. Similarly, your solution set for this, let us call the solution set for this inequality to be B. Then we write this as x such that x less than 5, x is a real number. Yes. Okay, so these are the two individual solution sets for the two inequalities. So then what is the combined solution set? Combined solution set, remember, will be A intersection B. That is whatever is common to both the sets. Let us say, therefore, hence, solution set of the given inequality will be the intersection of both the sets, A intersection B. Now, what should be A intersection B? If you see the set A, x is such that x is greater than or equal to minus 1. So I'll write x such that x greater than or equal to minus 1. Also, x is less than 5. So I'll give a comma and less than, write x less than 5 and x belongs to R. This is the combine. Now, if you combine these two inequalities, if you see x is greater than minus 1, right, and x is less than minus 5, that means you can combine this to write minus 1 less than or equal to x less than 5, where x belongs to set of real numbers. Why did I write it in this way? Because x is greater than minus 1, greater than or equal to minus 1, and x is less than 5. That means x must lie between minus 1 and 5. It can be equal to minus 1, but not equal to 5. So that is why I wrote x lies between minus 1 and 5. So combining this is the solution set. This is the way the solution set you can write. Now, how do you graph it on the number line? You take a number line, okay, and you give your points, okay. uh, at least you give because you see there's a 5 here, so at least try to give up till point 7 on this side, say till minus 7, and you take say till plus 7. Okay, you give your point. I'm not showing you the plottings. I'll just show you how to graph. So you have say a 0 here somewhere over here, and say you have a minus 1 somewhere over here, and say you have a 5 somewhere over here. Then how do you graph the solution set? So if you see equality is attached to minus 1, so you give a vertical line here, okay, and it is not attached to plus 5. So you give a curve here and you join these two. So therefore, all the points on this part of the line, which is very close to 5 but not touching 5, remember, okay, will give you the solution set. Any questions till this part? Any questions on any step? No question, then I can proceed with the next one. Okay, so the next one here is 26. I don't know whether I worked out 26. Yes, I worked out 26. So no need. 29. See, I worked out 29. Yes, 29 also is worked out. Hmm. Let us see number 35. 30 is there. 30 I'll solve after this. Let us see number 35 first. Number 35. According to this, if P is a solution set, 35. If P is a solution set of minus 3x plus 4 less than 2x minus 3, where x belongs to n. Okay. So replacement set here is the set of natural numbers. And so what is the solution set given? Solution set is P, which you have to find out. Okay. Next is the next inequality given is 4x minus 5 less than 12. Here the replacement set is the set of whole numbers. Okay. And solution set is given to be Q. Okay. You need to find first of all P intersection Q. You need to find the intersection of P and Q, and you need to find Q minus P. Let's see how to do these two. Now, what do you mean by P intersection Q? Can someone tell me what you mean by P intersection Q? Can anyone tell me what P intersection Q means?
All the elements of
That
P is
common
present.
element.
No, no. In the inequality sense, what P intersection Q means? In the sense of inequality, P is the solution set of this inequality, right? P is the solution set of this one. Q is the solution set of this one. That means P intersection Q will be the solution set of both the inequalities, in fact. Understood? That is what it means. So let us find out the solution set first. So we start with the first inequality. This is solution. We have minus 3x plus 4 less than 2x plus 3.
So it is 2x minus 3.
Is it? Okay, 2x minus 3. So minus 3x minus 2x less than minus 3 minus 4. So you've got minus 5x less than minus 7. Now again the same confusion here. So you need to make the coefficient of x1. So what we do here is we divide both sides by minus 5. Okay, and once we are dividing both sides by a negative number, we need to reverse the sign of the inequality. So this, remember, please remember this step. Although it looks like we don't have to reverse the sign if you do directly, but you will have to. X greater than 7 by 5. That means x is greater than, say, approximately, not approximately, exactly actually 1 point, if you convert to decimal, 1.4. So x is greater than 1.4. So what is the solution set here? P. So you see the replacement set here is what? Replacement set here was the set of natural numbers, right? So what are the natural numbers that are greater than 1.4? There are 2, 3, 4, 5, and so on. It continues till infinity. And because it is an infinite set, you can also write it in set builder form. X such that x greater than 7 by 5, x belongs to n. This is how you write in set builder form. Okay, so this is the solution set for the first one. For the second one, let's see, 4x minus 5 less than 12. So from here you have 4x less than 5 plus 12. You take 5 on the other side, so you get 4x is less than 17. Now you divide both sides by a positive number 4, so you don't have to reverse the sign of the inequality. And so you get x less than 17 by 4. That means x is less than 17 by 4 means
4.5.
4.25. 4.25. So therefore, what should be your solution set Q? What is the replacement set here? The replacement set here is the set of whole numbers. Okay. So if your replacement set is a set of whole numbers, so what are the whole number that are less than 4.25? 1, 2, 3, and 4 only. So this is a finite set. So that is okay. Okay. In fact, finite sets also you can write in set builder form, but it's okay. You don't need to write finite sets in set builder form. Okay. Try to write only infinite sets in set builder form. So that is what you have. The question here is first how to find P intersection Q. So let's see what is P intersection Q. P intersection Q is this set, this infinite set, intersection this set. And what are the common elements here between these two? 2 is a
2,
common
3,
element,
4.
3 is a common element, and 4 is a common element. That is P intersection Q. Okay. Next question is Q minus P. Q minus P, if you want to write Q first. So what do you mean by Q minus P? Q minus P means all the elements of Q from which all the elements of P have been removed. Okay. So all the elements of Q from which all the elements of P have been removed. Now see, 2 is there in P. Is it there in Q? I'll remove this. Okay. 3 is there in P. And so I'll remove this from Q. 4 is there. So I'll remove this also. So what am I left with only? Clear? Q minus P.
Yes, sir.
Okay. So that is what I think I have time for one more. And tomorrow there's a test. Unless if you have any doubts, you can ask because tomorrow I'll be taking a test on inequality also. So if you have anything that you need clarified, you can ask now. Okay. So let us take mm, let us take number 39. Let me take something that involves a fraction. Let us see 38. 38 is a better one. So you have 4x minus 19 less than 3x by 5 minus 2 less than or equal to minus 2 by 5 plus x. I think I have solved this in the in my this thing notes, but and still let's see. It's the better example. So do we divide this into two? What is the replacement set? Let us take first note of the replacement set. Replacement set is the set of real numbers. Okay. Now this consists of two inequalities, so we'll divide this into two inequalities. First inequality is 4x minus 19 is less than 3x by 5 minus 2. The second one is 3x by 5 minus 2 is less than or equal to minus 2 by 5 plus. So let us solve these two. Take x's on one side. 4x minus 3x by 5 is less than 19 minus 2, because we transpose 19 from minus 19 becomes plus 19. From plus 3x by 5 it becomes minus 3x by 5. Okay, now you can take the LCM. Becomes 20x minus 3x is less than 17. That means this becomes 17x by 5 is less than 17. That means 17x is less than cross multiplication, not cross multiplication, in fact, multiplying both sides by 5. Okay. Let me show you this step. Now we don't actually say cross multiplication, and we should not think in that way also. In order to remove 5 from the denominator, you multiply both sides by 5. This is the way you should think. So you get 17x is less than 17 into 5. So that means what is x? You need to divide both sides by 17. So you are dividing both sides by a positive number. You don't need to reverse the sign of the inequality. So that means that x is less than, here 17 cancels, you get x less than 5. Let's see the next one. In the next one, again you take the x's on one side. 3x by 5 minus x is less than or equal to 2 minus 2 by 5. Take the LCM now. You get 3x minus 5x is less than in 5. So you get 10 minus 2. You get minus 2x by 5 is less than 8 by 5. So in order to remove 5, you need to multiply both sides by plus 5. So you don't need to change the sign of the inequality. Okay, so it's minus 2x by 5 into 8 by x. Next, you have minus 2x is less than 8. And now, in order to make the coefficient of x1, you need to divide both sides by a minus 2, which is a negative number. So obviously, you will have to reverse the sign of the inequality. That means you get x is greater than minus 4. So what is the solution set here? The solution set here is, for the first inequality, it is x such that x is less than 5 and x is a real number. And for this inequality, the solution set is x such that x greater than minus 4 and x is a real number. So the solution set of both the inequalities will be the intersection of the two, A intersection B. In fact, the required solution, the solution set of the given inequality is A intersection B and is given by x such that now x is less than 5 and x is greater than minus 4. That means x lies between minus 4 and 5, but they are not, but x cannot be equal to minus 4 and 5, where x is a real number. And if you are plotting this on the real number line, then obviously your plotting will be, you have a minus 4, if you have a 0 here, and say you have a minus 4 somewhere over here, and say you have a 5 somewhere over here, and your solution lies between these two, and both of them are not equal. So therefore you give a curved line above minus 4 and plus 5, and you join this. So this is your number line. Okay, so I think I'll stop here for today.